All right, students, welcome back. We are now officially on the last day of Unit 2. We finally made it to the last day, guys. I know it's been some time. It's a large unit, but we have made it, and we are going to wrap up this unit with our second day of mountain types, where we left off yesterday with yesterday's lesson. Again, I'm going to post the writing assignment today as well for you guys to work on. I think that's going to replace the workbook assignment I had originally planned. And then hopefully by the day's end, I will have the 20 questions. It's going to be now a 20-question unit quiz that will be due later this week. So that'll be kind of finalizing this unit with the writing assignment and the unit quiz. So make sure you are ahead of things. You've got nothing missing. You've turned in anything that is missing. And again, because those grades are going to be set in stone very soon as we wrap up the quarter here by Friday. Going ahead, looking at our Go Blue though next, we've got number 1, what are the 4 mountain types and their key differences? Number 2, blank boundary types most commonly create mountains. That should be your answer. You should find that on page 15 of our notebooks. And number 3, which mountain type is the most common? Again, you are to write these questions and then answer them on your own on page 20. Please pause the video and work on those now. Okay, moving on to some of our answers here. Okay, we should all know the 4 mountain types. We went over them yesterday based on our sheet with the 4 columns. Okay, and we should all, if you look at the video from yesterday, I showed you completely how to set it up, so I'm not going to zoom in on this. But our first type is going to be the folded mountains. Second type is going to be the fault block. Third type is going to be volcanic. And 4th type is going to be the dome mountains, okay? Now, what are the details and specifics on that? Okay, folded mountains are going to be rock bending. These are kind of summing up kind of what we looked at with details yesterday, okay? So bending rock. Whereas fault block instead is going to pull apart rock and fracture it upward, okay? So pulling apart and fracturing that rock. Next, we're going to go over more in detail here in a little bit, but we have volcanic. Simply put, just it's a cone of lava and ash. Again, a cone of lava and ash, okay? And then lastly, 4th is dome. It's just like volcanic, but the magma pushes the rock up like a rock bubble, and it never gets the chance to explode. It doesn't get the chance to have an opening because that rock is simply too tough, okay? Oops. Excuse me, guys. Okay, so that concludes the mountain types, and we're going to go over volcanic and dome in more detail today. Next, we have our boundary type that most creates mountains, and it's going to be, guys, pretty simple, convergent. Okay, you're going to need plates coming together to have crust going upwards to the sky, forming those mountain structures. And then lastly, guys, looking at that as well, the most common types of mountains we went over yesterday were the first type, which would be our folded mountains. Folded mountains, again, can include the Himalayas, include the Rocky Mountains. Our most common type are going to be folded mountains, Okay, we're going to go ahead, and again, this vocab has been due for a while. No worries there. We're all good on that. Just in case you wanted to see it again. Okay. Where is the table of contents? Again, we finalized table of contents the other day with pages 20 and 21 on mountains. This stuff, we were at the Go Blue on page 20. This is going to be on page 21 as we continue from yesterday. So with that being said, let's go ahead. I'm just going to throw, let me find a question here. Just a random question. Or I'll throw one in later. Because I think a lot of my card questions are found in the presentations themselves. So why not just throw this review in here? Okay. So which size of waves are also known as longitudinal waves? The P wave, S wave, or surface wave? The answer is going to be positive. What do you think? P wave, P waves, guys. And this is going to be a little bit of review for your test, your unit quiz coming up, hopefully by tomorrow or later today. Which size of waves are the fastest? Pause the video. What do you think it's going to be? It's going to be our P waves again, primary waves. And which size of waves move up and down, back and forth, like up and down like that? Okay. And pause. You think the answer is going to be S wave, S wave. Why not do one more? Which size of waves are known to be the most destructive? Pause the video. See what you think it's going to be. The surface wave, again, surface waves do the most damage because they're at the surface where all the people in the buildings are, right? Okay, just a little old, why not do some old review? We'll have some new review here in a little bit. But I want you guys to go ahead, go back to page 20 before we, I got a really good video from Nat Geo, 2 good videos from Nat Geo today, actually. I want to check this first one, though, and write this question down. If we're learning about volcanoes, this is the last volcano day, I think, by the way, this school year, we might as well know why they erupt. Okay, so what causes volcanic eruptions in general? How is it that we get some molten rock, some magma flowing from out the mantle, all the way kind of seeping through the crust and then out to the surface of it? How does it happen? Why does it happen, right? Go ahead and write this question down on page 20 or 18 if you need more room. And let's go. I'm just going to show you a little sample of this, and I need you guys to watch this on your own to get. I need you guys to watch this on your own to get the full answer as well. So let's check it out.
Portals into the heart of the earth. They burn.
Pretty cool.
Bottomless cauldrons
Really?
fueled by an ancient wrath.
This is a video that was only released 7 months ago, and I think the old one they had was like 6 years old. So they've really updated some of the graphics. Really awesome stuff in this video, guys. I was excited to find this.
And boiling thousands of miles beneath the surface and just waiting to burst through.
Good visuals.
Volcanoes are scattered across the planet. About 1,500 active volcanoes can be found across the world, though countless others are on the ocean floor. Most volcanoes, whether on land or underwater, are located where tectonic plates meet. In fact, the Ring of Fire, a path that traces the boundaries between several tectonic plates around dome-shaped, lies. Major types include stratovolcanoes, which often appear as tall, steep mountains.
Pretty cool.
Shield volcanoes, which are flatter and dome-shaped. Calderas, which are large depressions in the ground. And mid-ocean ridges, which are underwater chains of volcanic mountains.
So again, you'll need to watch the rest of this. It's worth the full 5 minutes. It's very descriptive. I mean, one thing I can say, the visuals are phenomenal. These recent National Geographic videos are always the best. I really enjoy them. So go ahead and watch all of that. You need to know why and how do volcanoes erupt. We know what they are. They're cones of lava and ash. But why and how do they erupt? Why and how? Find that out as you go on your own. All right, continuing from where we left off from yesterday, I'll show the ice climbing video. We saw this one yesterday, so hopefully you remember it by heart, right? Which mountain type is the most common and involves rock bending? We just did it for Go Blue. It's A, it's folded. You guys know this. We did it yesterday. By the way, also speaking of volcanoes, what is the difference between magma and lava? What is the difference, magma and lava? What could possibly be the difference? You don't need to write this down. We're just kind of talking about it. You will write it down anyway. The difference, guys, is going to be that magma is still within the ground, okay? Lava has reached the surface. So it's molten rock. It's the same thing. It's all about location, okay? So one's in the ground, the other one is at the surface. Lava at the surface, magma in the ground. So go ahead. You need to go back to page 21. You need to go to the third column here. We are on the volcanic column on the right side, or whatever side was open from the illustration you guys drew yesterday. Okay, and let's talk about volcanic, specifically volcanic mountains, right? Just a cone of ash, cone of lava, okay? And molten rock within the earth erupts and piles on that surface, right? Piles on that surface. And we already know lava's at the surface, magma's in the ground. Examples for us include Mount St. Helens and Mount Kia. Again, Mount St. Helens and Mount Kia. Now, can volcanoes just stop working? Can they go extinct? Can they die? Well, believe it or not, they can, guys. Volcanoes do go extinct. They do become inactive for millions of years, maybe forever, but sometimes they can become active again. All it takes is for that volcano to have a source of magma once more. Once that magma runs out, once that magma is cut off, that volcano will no longer erupt and it will go extinct. Kind of like the volcano you see in the picture below. All right, so no question for this video. I do want to show you guys, if you are interested in mountain climbing, I've gone skydiving, right? I've never gone mountain climbing, but some extreme mountain climbers, what they will do when they set up their tents to sleep at night, if they're traversing the most extreme of mountains, they're not always going to have ledges to camp on. So what do? Believe it or not, they actually take their tent equipment, they take their harnesses, and just like you would a hammock to a tree, okay, they're going to hook and harness their tent literally on the side of the mountain, hanging off the side of the mountain like a hammock. So basically the only thing holding you from falling off that mountain is like a nylon floor of that tent as it hangs hooked to the side of the mountain. I know me, I've gone skydiving. It's not something I would do. Not something I would do. I'm too afraid of heights. It's one thing to jump off a plane and have your adrenaline rushing, okay? As you're falling from the sky, it kind of happens so fast, you just accept it, right? But when it comes to heights that I have to like process like in real time or slowly, right? If I'm looking down a tall building, I lock up. It scares me too much. So I wouldn't do this, but let's take a look at what this setup looks like. And you guys get an idea as to see if you would do it or not. It's a pretty cool video here. And that last video of the day, by the way.
Day 11.
So here they are.
Kentucky Suite as well.
It's only 24 square feet. We have two mountain climbers in the tent.
You kind of gotta want it though.
If you don't want it, it's worth nothing. It's penance. This could be.
Otherwise, it's a pretty comfortable place. We've got.
And mind you guys, again, they are not on a ledge. They're hanging on these tether lines that are attached to the side of the mountain. There is no floor. It's just like a hammock, but instead of trees, they're hanging off the side of a mountain.
24 square feet living area here. Doesn't seem like a lot, but it also doubles as the sleeping quarters. So think of like a lot of storage up high. Get everything out of the way.
And then here you can see kind of the tether lines that are inside the tent. And let's take a look at the side of the mountain. What does the view look like on the way down? Or like look like from outside?
10 days of hauling.
Pretty beautiful, but also frightening view.
A little bit of A4 at 20,000 feet. Right.
Check it out. That is the view on the way down. Thousands of feet in the air. Absolutely insane. I wouldn't do it. I don't know. Maybe some of you would. I don't know. I think most of us wouldn't.
No elevator service. Sorry.
There's no floor. They're not on a ledge. It's hanging off the side.
But where do you get a view like that?
And then you can kind of see, just to get an alternate view of these other mountains, guys. I mean, look at how steep these things are. These are not just regular, ordinary mountains. These are very steep, some of the most difficult mountains to climb. I think these are in northern India or in the Himalayas, so pretty fascinating, cool stuff there. All right, let's finish up with our last mountain type of the day before we do our last practice question of the day. Last mountain type is the Dome Mountains, guys. This is the last thing we need to know for Unit 2. Oh, it's been forever. It's been a month-long unit, I believe, if I'm not mistaken, maybe more. All right, so think of Dome, and this is, look at this picture. It's pretty cool. I mean, this looks like something out of a Dr. Seuss book. It really does. How do we get these things? Well, what happens is magma pushes the rock up kind of like a rock bubble, okay? And unlike a volcano, that rock is too tough for that magma to pierce through and have the magma come out of that mountain, okay? So basically the magma pushes up and it kind of just solidifies rather than spewing out of the mountain. And you just get this kind of lump, you get this kind of bubble-like structure, this rock bubble, right? And that's it. It's a rock bubble that got pushed up by magma that could never get through, okay? And it forms a dome shape. I'd imagine these would be pretty cool to climb. I don't know why I could not find any cool Dome Mountain videos on YouTube. Maybe you could find some. I looked around for a little bit. I couldn't find anything. I know there's a cool one in Georgia called Stone Mountain, probably 7 hours away. So if you ever want to see one in person, check that one out. There's a park around it, really cool. But yeah, that's dome mountains. They're I think kind of rare. I think sometimes these can explode and it's rare, but it's very dangerous. But most of the time they're very old and they've solidified already. So we're all good on that front. So guys, that concludes page 21. We know all the mountain types. We know the fault types. We know the boundary types. We even know the convergent boundary types. Whole lots of classification, whole lot of categories in our space science, and a lot of vocab. I'm not always the biggest fan but I do love teaching it, and I do have to follow what the state of Florida wants us to teach for the curriculum. So just giving you guys my view on that. But let's go ahead, guys. Again, example is the Fairview Dome. That's a picture down there. You see there's a road going through it. No, that road is not going to go over it. It's probably going around the mountain. But let's look ahead. Last question today. Which mountain type forms from Earth's crust fracturing and pulling apart? Is it A, folded, B, fault block, C, volcanic, or D, dome? Pause it, see what you think. The correct answer is going to be B, fault block. That was in our Go Blue earlier, right? You just got to know what we just learned about. That's all. Again, B, fault block. All right, guys. Let's go ahead and call it a day. Last Unit 2 video lesson. I'm going to go ahead and probably try to make tomorrow just the day for the unit quiz, because it's 20 questions. I want you guys to have time to do that. And we're going to start our Unit 3 Thursday and Friday. So really, really spend time on that unit quiz. Don't take it until your notes are up to date. And really spend time looking over your Canvas, seeing what you're missing, getting your stuff up to date. Okay? This is Mr. Campbell signing out. I'm going to respond. I got a lot of messages to respond to. I got emails to get back to, so I will get to that ASAP afternoon today. Mr. Campbell, signing out. Oh, I got a lot of grades to update too, so we'll get to that ASAP. No worries, guys.